Hello friends, welcome again. Today we are going to study again a new topic, chemical effects of current. Electric current I am talking about, okay. Electric current, now you all must have come to know about electric current. The electric current has many effects like heating effects, magnetic effects. One more effect is the chemical effect. So today we are going to learn something about chemical effects. Now chemicals, you know what are chemicals. We are linked with chemistry for chemicals. So chemistry and physics, a little bit mix up of both. So when we talk about chemical effects of electric current, it means there are some chemical changes in the chemistry of a element due to electric current. Okay, so we'll talk about all those things. Before going to that topic, let's recap a few things like conductor, a non-conducting substance, a conducting substance. You all must have studied that metals are a good conductor. So I can say anything which can pass electric current through it is called as a conductor. Until now you all have read that conductors are generally solids. Conductors are in the form of solids, but here we will see that there are certain liquids also which are conductors. Okay, so before proceeding, let's see a few terms. Let's recap a few terms for this chapter or for this topic, some of the things which we should know. Okay, so few of those things over here. All the first, let's talk about conductors and non-conductors. So you know that materials that allow electricity to pass through them are called as good conductors, and those which do not allow the current, the electric current, to pass through them, they are called as poor conductors, bad conductors, or insulators also. Okay, so this way we can classify a substance into two parts: conductors, non-conductors. Okay, conductor, insulator. Non-conductor can also be called as an insulator or a bad conductor, or you can say a poor conductor. So generally talking about metals, when we talk about metals, we find them, they are good conductors. You must have seen wire of copper or aluminium. Okay, so metals are good conductor, whereas plastic, rubber, wood, paper, they are bad conductors. They are insulators. They don't allow the current to pass through them. Okay, so now it's clear what is a conductor, what is a non-conductor or insulator, or I can say bad conductor. Okay, moving further, how much current can pass, how easily a current can pass through a conductor, that is called its conductivity, that is called its electrical conductivity. So if a substance is a good conductor, it has good electrical conductivity. Like copper has a good electrical conductivity, silver has the best electrical conductivity, aluminium also has a good electrical conductivity. But substances like insulators or bad conductors, they have no conductivity. Okay, so we can classify as a good electrical conductivity or a bad electrical conductivity. So I can say that insulators, or you can say non-conductors, have poor conductivity or no conductivity at all, but a good conductor has a good conductivity. Okay, so conductivity depends upon the atomic structure of different elements. Among the metals also, some are very good conductor, some are less conducting. So we can say that conductivity, some of them has very good, some has fair good, and some has low conductivity. So that's a matter of higher classes. At present you should know what is electrical conductivity. That's enough for it. Okay, moving further, is a substance conductor or not? How can you check it out? Yeah, you did an activity in previous class by making an electric circuit, which I can call as a testing circuit or a tester circuit. You can see a figure over here. This figure is a simple circuit which you can use at home to check whether a given article is a conductor or an insulator, or I can say it is a good conductor or a bad conductor. You can say this circuit, it consists of an electric bulb, a cell, source of current, and then the circuit, you can see it has a gap in between, so the circuit is not yet complete. Now what is to be done? You are given an article, suppose any article you have, just place it between these two contact points. By placing that article, or I can say by touching the end of the articles at these 2 points, if my bulb glows, it is a conductor, that article is a conductor. But if the bulb doesn't glow, it means that object is a insulator, or I can say it is a poor conductor of electricity, I can say this way. So this circuit you can make at home and check it out, different articles. Okay, as always I tell you, any kind of activity do under the guidance of some elders, don't do it alone. Okay, so I can give you 2 different diagrams. Now there is some difference in this diagram and this one. What is the difference? Over there I gave you a bulb, and here I am having a LED light, LED, light emitting diode. Why I am using an LED? Sometimes what happen, some of the substance have low conductivity, so the bulb doesn't glows properly because the bulb uses heating effect. So not so much heat is produced if the conductivity is low, so the bulb doesn't glow in spite of the object being a conductor, a slightly less conducting. Okay, so the bulb doesn't glows. So if I am using an LED, LED glows with a small current also, it consumes very less current. Okay, nowadays more often you can see LED bulb, LED TV, LED lights. Why do we use LED? Because they consume less energy. So LED glows much easily with a small amount of current also. So here in the place of bulb we have used an LED. Okay, so you can see the same circuit. In the first circuit I put a plastic spoon over there. Between the 2 points we have a plastic spoon, but in the next another diagram I have a paper pin metallic. So what do you find the difference? You can see here in the first the LED is not glowing, but in the second figure my LED is glowing. So what do we conclude? This is a conductor, that is not a conductor. That plastic spoon, or I can say plastic, is not a conductor, whereas this metallic pin, so metal is a conductor. So this way you can classify conducting, non-conducting, conductors, insulators. You can classify the articles which you have. Okay, so this way we can classify. Moving further, some of the new things again. One more tester I can design. Now this is a tester which is based on magnetic effects of current. Okay, so here I have placed a compass, a magnetic needle which rotates in the presence of a magnetic field, and then I have a wire, coil of wires winded around that compass and then connected to the cell. Okay, so if you again, my circuit is incomplete over here, there is a gap over here. Okay, now I have put something over here. If you connect this gap with something conducting, there is a flow of current in this, and when there is a flow of current, it's going to produce a magnetic field over here. This magnetic field is going to deflect the compass needle. So overall, let's summarize what's going to happen. If there is a flow of current, the compass will turn. Okay, and flow of the current will only be if this object, whatever I have put over here, is a conductor. Okay, so you can see in this, you can observe over here, the moment you connect it and if the compass rotates, okay, then I can say that this substance is a conductor. If the compass is not turning, the compass needle is not moving, it means the object is not a conductor. Let's see it again. Okay, you saw over here, the moment the circuit is complete and if the compass rotates, not completely, if it deflects a little, it means there is a current in the circuit, and if there is a current in the circuit, it means that this article is a conductor. So this is one more way of making a testing circuit, okay, for conductor or a non-conductor. Moving further, do liquids, I told you in the beginning, liquids also conduct electricity. Do you know this? Have you ever heard about it? Let's see. So the question is, do liquids conduct electricity? My brainy has a question. Does it conduct electricity? So to find out that a liquid conducts electricity or not, let's do an experiment. Okay, let's design an activity. Now the activity is, again, we are having a tester circuit again over here, the cell, the 2 points. Okay, you can see the circuit is still incomplete. The 2 wires are there in the beaker which are not connected to each other. Okay, so now we have a beaker over here, the 2 wires just made to move in the beaker, and then you pour a liquid in the beaker. Whatever the liquid you want to check it out, is it conducting electricity or not? Just pour in the beaker and fill it to the wire. Let both the wire be immersed in the liquid. Fill the container till the wire gets immersed in the liquid sufficiently. And if the bulb glows, it means the liquid is conducting. But if the bulb doesn't glow, the liquid is not a conductor. Simple. Okay. So let's see this activity over here. What's happening over here in this? I can have a look over here. We are filling it with liquid and the bulb glows. If you are filling it with a liquid and the bulb glows, it means that the liquid is a conducting liquid. Okay, quite simple. But if it doesn't glows, okay, you can see in this one more activity over here. Again, I am filling this container with a liquid. The bulb is still not glowing. If the bulb is not glowing, it means that this liquid is a non-conducting liquid. I can try this experiment with the tap water. You can do this experiment with a lemon juice. You can do this experiment with some cold drink. You can do this activity with some edible oil. You can try these things, okay? And under the strict guidance of some elders, you can try with some dilute acids also, okay? You can try this also. You can try it with soap solution also. You can see that it is a conducting or not, okay? So just take few of these liquids and try at home. We will get to know which of them are conducting and which of them are not conducting. I have made a list of these things. Let's have a look on the list that I have with me. So you can have the look on the table that I have prepared after performing these activities. I have taken some liquids like lemon juice, tap water, vinegar, alcohol, petrol, kerosene oil, mustard oil, dilute hydrochloric acid and dilute potassium hydroxide, and tried that activity of that bulb. So I found that bulb glows in some of the liquid, but it doesn't glows in others. So the liquid in which the bulb glows is a good conductor, and the liquid in which the bulb doesn't glow is a bad conductor. Simply, so you can see over here, lemon juice, tap water, vinegar, the bulb glows. It means it is a good conductor. These are good conductor, okay? But if you see alcohol, petrol, kerosene oil, mustard oil, the bulb is not glowing. It means they are bad conductor. Again, in dilute hydrochloric acid and dilute potassium hydroxide, the bulb is glowing. So I can say that they are good conductors, okay? So overall, to summarize, if we talk about these liquids, I can say one thing, that all solutions of acids like vinegar, it was a weak acid, hydrochloric acid and potassium hydroxide is a base. So all solutions of acid or base, even salt solution, the salt that you eat, even if you make a solution of that, it is going to conduct electricity. So all solutions of acid, base and salt conduct electricity, okay? So they are good conductors, okay? But liquids like oil, you can take kerosene oil, petrol, alcohol, edible oil, even alcohol solution, they do not pass current, so they are bad conductor. I can say they are poor conductors, okay? So I can classify. So now one thing is clear, that there are liquids which conduct electricity, okay? So do we have a specific name for them? Yeah, those liquids we call them as electrolytes. Electrolytic solution or electrolytes we say, okay? So let's clear little bit about electrolytes or electrolytic solution. What are these things, okay? So let's talk about electrolytic solution and electrolytes. Electrolytic solution, any solution that conducts electricity is called as an electrolytic solution. Okay, you can prepare an electrolytic solution yourself. Simply take 100 ml of water, add a spoon of salt, dissolve it. It is an electrolytic solution because it is going to conduct electricity. How? Why does it conduct electricity? Because when you added salt in that water, it produced positive and negative charges in the solution. So an electrolytic solution consists of positive charge particles and negative charge particles. Okay, so solutions that conduct electricity are called as electrolytic solution, and these solutions consist of positively charged particles and negatively charged particles. Okay, they come from the solute that you are adding in that. Okay, so that solute is called as electrolyte. The solution is electrolytic solution, but that substance that you have added, which makes that positive and negative charge, is called as electrolyte. So I can say, what is electrolytes? They are chemical compounds that conduct electricity when dissolved in water or when they are in molten form and electricity is passed through them. Okay, they break up and bring positive charge and negative charge. So electrolytes are chemical compounds or molecules, you can say, whose molecules dissociate into positively and negatively charged ions when electricity is passed through them or in the molten form, through the molten form. Okay, so we can say them electrolytes, and those compounds from which we don't get positive and negative charges, those compounds are called as non-electrolytes. Okay, so a non-electrolyte, if you dissolve in water, it's not going to dissociate. Okay, neither if you pass electricity through them, it will not allow the electricity to pass through them also. Okay, because if you talk about electrolyte, if you take an electrolyte in molten form, do you understand? Melted form. Okay, an electrolytic substance, if you take in a molten form and pass current, you attach it to a circuit, it will dissociate into positive and negative ions. Okay, or if it is dissolved in water, we call it aqueous solution. So if it is dissolved in water, it breaks up into positive and negative charges. So we call it as electrolytes. Okay, so electrolytes are the substance. The solution is called as electrolytic solution, and non-electrolytes, which do not allow the current to pass through them. Okay, like we talked about alcohol, we talked about kerosene, we talked about edible oil, those are non-electrolytes. Okay, let's figure it out by some pictures. What are these? Now this is an electrolytic solution. Let's say it is a salt solution. Salt, if you add salt into water, it's going to give you positive ions and negative ions. You can see in this figure, the negative ions and positive ions. Charged particles are called as ions. Okay, so I have a positive charge, I have a negative charge. This type of solution which contains these charged particles is called as a electrolytic solution, and this helps in conducting of electricity. Okay, moving further, electrolytes. Let's talk about electrolytes. Now electrolytes are also compounds which have positive and negative charges with them, but they are bounded to each other. They are not separate. But if you pass current in their molten form, or if you add this in the water and if it dissociates, then I can call it as a electrolyte. Let's check it out. What happens? If you add it to the liquid, you can see over there it is dissociating. The positive and the negative charges separate out. So this type of compounds are called as electrolytes. When they are added in water, they separate, or if current is passed in their molten form, then also they separate. So such type of compounds are called as electrolytes, and the moment they have positive and negative charges, they conduct electricity. Okay, so now it's clear what is an electrolyte. It's quite clear, I think so. So now if we talk about non-electrolytes, just go the opposite. What opposite? They are not going to dissociate. This breaking up is called as dissociation. Okay, so if it is a non-electrolyte, it's not going to dissociate in water, or even in the molten form, if you pass electric current through them, they are not going to dissociate. Okay. So, here you can see this is again a compound which I am adding it to the liquid water. You can see the molecules still they are intact. The positive and negative charges are bounded to each other, they are not separating. So, such types of compounds are called as non-electrolytes, or I can say they are not going to conduct electricity. Is it clear? Non-electrolytes. Okay. Moving further. So, before we move further, now it is clear, liquids which conduct electricity are called as electrolytes. Okay. Electrolytic solution you can say. And we have compounds which make the electrolytic solution, they are called as electrolytes, and those which do not make are called as non-electrolytes. Okay. Now, I told you about ions, positive charge particles and negative charge particles, they are called as ions. Okay. So, what is actually an ion? Any atom or a molecule which has a charge attached to it is called as ions. Or I can say when an atom or a molecule it loses electron or gains electron, it forms ion. Okay. So, I can say an electrically charged atom or a molecule can be called as a ions. Broadly classified, there are two types of ions, positive and negative. We have the name for both of them separate. Okay. So, you can see the name cations. So, if an atom loses an electron, it becomes positively charged, because you must have studied in the previous classes, even chemistry, that an atom is made up of positive charges and negative charges. Okay. So, if and both are equal in number. If an atom loses negative, it becomes positive. If an atom gains negative, it becomes negative. Okay. So, if an atom loses negative, now negative is electron. So, if an atom loses electrons, it becomes positively charged and it is called as a cation. Okay. So, when an atom loses one electron or more than one, it can lose 2 also, it can lose 3 also. Okay. At present 3, 1, 2 or 3. So, if an atom loses electrons, it becomes positively charged particle and then it is called as a cation. Whereas, if an atom gains electron, it becomes negative. Okay. And then it is called as anion. It can gain 1, 2 or 3. Okay. So, gaining an electron becomes anion, losing an electron becomes cation. Cations are positively charged particles, whereas anions are negatively charged particles. Okay. You can see here in this figure, there are 4 positive, 5 negative. Overall, the charge is negative, anion. Over there, 4 positive, 3 negative, 3 electrons. So, overall my charge is positive, that is the cation. In any of the atoms, the number of plus charges is always equal to the number of negative charges, always. Okay. The moment it upgrades or downgrades its negative charge, it becomes a positive or negative. Okay. So, here you can see it has one excess negative, so it is a negatively charged, and there it has one excess of positive, so it is a positively charged particle. Okay. So, when I talk about the positively charged particle and negatively charged particle, we are talking about cations and anions. Okay. So, quite clear what is a cation? A positively charged particle. And how is a cation formed? When an atom loses an electron. Anion is a negatively charged particle, and how anions are formed? When an atom gains electron. So, quite clear, cations, anions. Okay. Moving further, chemical effects of electric current, the main topic of this chapter. Chemical effects of electric current. What happens when an electric current is passed through a electrolytic solution or an electrolyte, you can say, or a chemical. So, when an electric current is passed through an electrolyte, some chemical reaction takes place in that chemical, and that effect is called as chemical effects of electric current. Due to the passage of current, some chemical reactions happen due to current. So, it is called as chemical effects of electric current. Okay. To pass a electric current through a solution, we have a setup. You can see a setup over here, this figure. We have a container. The container in which this activity is done is called as an electrolytic cell, or you can also call it as a voltmeter. You can see over here, it is called as voltmeter. Okay. Now to pass the electric current through the solution, I need some connecting thing. So we generally use two rods. These rods are made up of metals, or it can be a carbon rod. Okay. So we use two rods which are called as electrodes. You can see the two rods over here. One is marked negative and one is marked positive because it is connected to the positive terminal. This rod is connected to the negative terminal. So the rod which is connected to the negative terminal is called as cathode, and the rod which is connected to the positive terminal is called as anode. Remember this thing: cathode, the electrode which is connected to negative; anode, the electrode which is connected to positive terminal of my source. Source is my battery. Okay. So by this means we are supplying current to the solution, and it is an electrolytic solution. So it has positive charges and negative charges in the solution. And you know this universal fact: opposite charges attract, same charges repel. So from the solution, the positive charge particles will be attracted towards the negative rod, and the negative rod is my cathode. So I can say that the positive charge particles or the cations in the electrolytic solution are attracted towards the cathode. Okay. Whereas the negatively charged particles, which are called as anode, they are attracted, which are called as anions. Sorry. Okay. So the negatively charged particles, which are called as anions, they move to the anode. Okay. So this way the particles move in the opposite direction. Okay. Why? Because opposite charges attract. Okay. So the cathode attracts cation, the anode attracts anion. So there is some chemical effects happening over there. So this complete effect is called as chemical effects of electric current. So I think you must have understood this labeling over here. What do we call these things? Whatever is here, this rod, electrodes, two types, cathode and anode. The solution, electrolytic solution. The container I call as electrolytic cell or voltmeter. Okay, it's clear. So whenever this thing is done, this process is called as electrolysis. What do we call it as? Electrolysis. The passing of the current through an electrolytic solution is called as electrolysis. So whenever this thing is done, chemical effects takes place. And how do I come to know that there is some chemical reaction going on? How can I come to know? I can't see these particles. So how will I come to know that there is something happening over here? There must be some changes over here. You can see that. There will be some bubble formation, or there may be a change in color of the solution, or there may be some deposition, some formation of some chemicals. Something can happen. Some changes you can see in that container. So that indicates that there is some chemical reaction going on. So moving further, these are some of the common terms which we use for this process. The first one, electrolysis. Quite clear now? What is electrolysis? Yeah, the passing of the current through an electrolyte, and when you pass the current through an electrolyte, that electrolyte decomposes. It disassociates into positive ions and negative ions, and that process is called as electrolysis. It is done in a container called as voltmeter or electrolytic cell. So we have discussed these things, and it's for you to understand the container, whatever. It can be a glass container, it can be a plastic container in which we are doing that activity, and that container is called as electrolytic cell or voltmeter. The electrodes, the two rods which help in connecting the circuit, is called as electrodes. They are called as electrodes. There are two types, cathode, anode. What is cathode? The rod which is connected to cathode. I am talking about cathode, which is connected to the negative terminal, is called as cathode. The electrode which is connected to the positive terminal, called as anode. Okay. Anode attracts anions, cathode attracts cations. Okay. Then we can see effects of current. What are the effects? I told you. What changes do you find? what can happen? You can see some bubble formation. Bubbles are formed and move up. You can see again what happens. You can see bubble formations which moves up. This can happen during electrolysis. What else can happen? You can see over here also. On one of the rod, you can see some deposition of some metal deposition. You can see the color change of the strip electrode. On one of the electrode, some of the metal particles, they get attached to it. Okay, this happening you can see over there. Or it can also settle to the bottom also. It can precipitate out also. Or you can see one more change, the change in the color of the solution. You can see over here there are some change, from blue it changes to green. There can be some other colors also. This is just an example. If the color of the solution is changing, it means some chemical reaction is happening over there. So these are the few things which you can observe during a chemical reaction due to passing of electricity through an electrolyte, or I can say these are the chemical effects of current. Okay, so these are things which you can see while happening of electrolysis. One more activity you can perform at home also, when you pass electricity through water. Now water, if I talk of pure water, it is not a conductor, but the water which you drink or the water which is tap water, you can say they are conductor because it contains salt. Okay, so they are a conductor. So let's take a conducting water. So how can you make a conducting water? Take tap water, or to make it more conducting, you can add a few drops of lemon juice. Lemon you can add to it, it becomes more, conductivity increases of that water. Okay, if you add lemon, or 1 or 2 drops of acid also. Okay, dilute acid if you add to the water, it becomes more conductive. Okay, so the conductivity of the water increases. Now if you put 2 electrodes, you can use 2 electrodes at home. You can use 2 screws or nails as an electrode, connect it with the wire, then connect it to the ends of a cell or a battery. You can see, if you connect it to the positive and negative end, immerse in the water and apply the current, you will find bubbles appearing at both the ends. So it means some gas is being formed in the water which is coming out. You will see bubbles moving up. So I'll tell you what the bubbles are. If you know the formula of water, what is the formula of water? H2O. H, hydrogen, O, oxygen. So I can say water is made of hydrogen and oxygen. So when you pass electric current through water, this compound disassociates. It breaks up. It gives you hydrogen and it gives you oxygen ions. Okay, oxygen is a negative ion and hydrogen is a positive ion. So the positive ion will move to the cathode and the negative ion will move to the anode. Now what's going to happen? At negative point, bubbles coming out will be of hydrogen. Okay, so hydrogen and oxygen are produced. Oxygen bubbles are formed at the anode. Why anode? Anode is connected to the positive, oxygen is negative, it is attracted towards the positive terminal. From the positive terminal, it gives out negative charge and becomes molecule oxygen and it is evolved. So what happens over here? At positive we get oxygen bubbles, at negative we get hydrogen bubbles. Okay, so the gas water breaks up, it gets disassociated. The chemical formula of water is H2O. So H and O are separated due to the passing of electric current. So I can say this is the chemical effect of electric current, that is breaking up water molecule. Okay, so this activity can be done at home also. One more important feature of electrolysis is electroplating. Electroplating nowadays you can see in many of the phenomena, many of the things electroplated. What is electroplating? First of all, electroplating means depositing a layer of a desired character material, desired metal on another metal. Okay, suppose I need something, I need a rod of gold, too expensive, I can't afford it. So what do? I take a rod of any metal, low quality, inferior quality, and then get a layer of gold deposit on it, a thin film of gold deposited on the surface. This process is called as plating, and when this is done with the help of electricity, we call as electroplating. So electroplating is a phenomena of depositing a thin layer of desired or I can say superior metal on another material by means of electricity. That is called electroplating. Okay. You must have seen the handle of your cycle or motorbike, they are shining, or the rim of the cycle, they are shining. Some tin objects, the utensils also, they are having a shining appearance. Some objects have gold appearance, some have silver appearance. They have a coating of these materials over inferior quality metal. Okay. So electroplating we do to protect some of the metals from some corrosion effect, or making them more attractive also we do the electroplating. So electroplating, how is it done? Let's see an activity. Let's see how electroplating is done. So for electroplating we need the process electrolysis. So we are going to do electrolysis over here for electroplating. Now electroplating, I need to apply a coating of silver or gold or copper, whatever, it's up to us what kind of coating we need. So one thing is to be sure, one thing we have to keep in consideration, that the solution we are taking over here as an electrolyte, it should be a salt of the same material. Suppose I am thinking to coat of silver, so this solution has to be a silver salt solution. If I need a coating of copper, then this solution should be a copper salt. If I need a coating of some other material, so this solution has to be a salt of the same metal whose coating is to be done. Clear? First thing. Second, on what material I have to coat. Suppose I have to put a coat on this material, so this metal has to be connected to the cathode. Okay. The material which is to be electroplated, it is taken as cathode, and that superior metal whose coating I have to do is taken as anode. Remember this thing. Suppose I want to do a coating of silver, then my anode is going to be a silver, my cathode is going to be that object, whatever has to be coated, and the solution has to be a silver salt, and then we do this thing. Okay. So once you keep the solution, a solution is electrolytic solution, so it will have positive charge and negative charges in it, and the moment you pass current, all the positive charges will be attracted towards the cathode. Let's have a look over here what happens. You can see the solution, then these two plates over here, and that's what happens. What I have done over here, let's imagine we are doing a coating of copper. Okay. So you can see over here the negative rod, the cathode is that, let's take any random metal, inferior quality plate on which I need a good appearance. So I have taken that as a cathode. I need a coating of copper, so I have taken the anode as a copper strip. The copper strip has to be the anode, and the solution has to be a copper salt. Let's take copper sulfate. So here the solution is copper sulfate, which has positive ions and negative ions. The moment the current is passed over here, the copper in the solution gets attracted towards the negative, because copper metal is a positive charged particle. Metals ions are positively charged. So the copper is being attracted towards the plate and sticks to the plate. Okay. And whereas the copper from the rod gets dissolved in the solution. Okay. The copper starts forming copper ions and give it to the solution, and from the solution the copper goes to the metal, whatever the metal plate I have, I can say the cathode, and sticks to it. So slowly a layer of that copper deposits on my cathode metal, and this process is called as electroplating. Okay. So this is how it happens. Step by step I can write it, I can summarize it, that when copper sulfate is dissolved in water, it forms the positively charged copper ions and the negatively charged sulfate ions. Okay. These two charges particles are already there in the electrolytic solution. Now when you dip the plates, the electrodes, one is copper, other is the metal on which I need a coating. Okay. So when you dip it and pass current through it, what's going to happen? Okay. So the negative electrode, I can say the cathode, attracts the positively charged copper ions, and they go to that cathode, give the, okay, they are positively charged, go to cathode, take electrons from the cathode and stick to it. Okay. So when electric current is passed through the solution, the cations, copper ions, move towards the cathode and the anion sulfate move towards the anode. That's you know that the positive will move towards the negative electrode and the negative charge will move towards the positive electrode. Now at cathode, I am talking about the negative electrode. At cathode, the copper ions gain electrons because copper ions are positively charged. They will gain electrons from that plate and then get attached to the plate. They will deposit themselves. Whereas at anode, the copper atoms from the anode plate, the copper atoms will detach and become charged and come to the solution. So there is no loss of ions from the solution. Whatever the copper that goes to the negative electrode, the solution receives the same amount of copper from the anode. Okay, so this way anode from the plate, from the copper ions from the plate get transferred to the electrode and forms a thin layer on that cathode, and that process is called as electroplating. We can do the same with silver, or we need a gold plated, or decide whatever we need over there. Okay, so that is electroplating. It is used in many of the industries, many of the articles which you see around you, they are electroplated. It is a very useful process, widely used in industry for coating metals, a thin layer of surface we have there. For example, chromium plating is done on many objects such as car parts, the shining chrome, we say no, chrome plated, that is chromium metal. It has a very shiny appearance, okay, and it is scratch free type of layer. So we use it for car parts, bath taps, the taps in your washroom, that was shining, that is again because they are chrome plated. Taps, kitchen gas burners, bicycle handles, wheel rim and many other things which are chrome plated. It has a shiny appearance and does not corrode. It resists scratches also up to a certain limit. Okay, so electroplating is useful in these things. Some places more, like jewelry. Those jewelry makers, because jewelry is too expensive, so in spite of making the whole object of the expensive material, we simply make of any copper or anything and then we coat it with silver or gold. So jewelry makers electroplate silver and gold on less expensive metals. These ornaments have the appearance same like silver or gold and are cheaper than pure one. Okay, so it is used over there also. Even the tins and cans, like cold drink cans which we use, so they are tin plated, because tin again over here, it is a non-corrosive substance over there. So we tin plate the cans which are used for storing foods, we do over there electroplating of tin. Zinc is also used, like you can see bridges and many infrastructures are made of iron, but iron has a one negative point, to get rusted. It gets rusted in the presence of moisture and air. So to prevent from rusting, a zinc coating is given on the iron. Okay, so prevent from rusting. So coating of zinc is deposited on iron. Okay, this process is also called as galvanization. Okay, to protect it from corrosion and formation of rust. So these are some of the applications of electroplating. Okay, but electroplating, if I talk about, everything has some plus points, some negative point also, because that solution which is left after electroplating, if you can't simply discard it off, you can't simply throw it off, it is going to create pollution. So it has to be discarded by certain methods which has been given, some directions are there to dispose them, otherwise they can cause soil pollutions also. Okay, now here you can see some figures, they are all electroplated. You can see the alloy wheel shining, the chain over here, the shining, the tap over here, you can see it has a shiny appearance due to chrome plating. These are all electroplated articles. Okay, it's not that the complete material is made up of the same shiny thing. Okay, it's only a thin layer on the top. Okay, so now in electroplating factories, the disposal of used solution is a problem. Okay, so it is a polluting waste, so it is not simply discarded here and there. Okay, there are certain guidelines made by government to make it ineffective, and then only we can discard, so that it becomes a non-pollutant thing. So that was all about electroplating. So I think now it's clear what is electroplating. The chemical reactions which happen over there, when you go to higher classes, you will understand the equations also, how do this exchange of ions and all this takes place. Here just a brief idea what happens during electrolysis, or I can say electroplating. Okay. So, these effects whatever you studied here, they were, what was these? These were the chemical effects of electric current. Okay. So, one thing we have learned today, that electric current can be passed through liquids also. So, there are certain liquids which conduct electricity. These are called as electrolytes. So, let us summarize it up. We talked about conductors, good conductors, bad conductors. We talked about liquids which can conduct. They are called as electrolytes. Okay. Now, electrolytes contain ions. Ions are of two types, positive, negative, the cations and the anions. And the process of passing current is called electrolysis. Electrolysis, we have rods, electrodes, the cathode, the anode. Cathode, the negative rod, anode, the positive rod. Okay. Electrolysis is used in many fields, like one of the field we have talked about electroplating. It is also used in refining of metals also, electro refining we call over there. Okay. So, that you can study in higher classes also. Okay. So, just have a recap. Meet you next time. Till the time, bye bye, have a good day, bye.